Hello everyone, welcome back to the next lesson on permutation combination. In the last lesson we have seen a brief intro, very short intro of course it was, of how to split permutation combination questions, which will always ask you for counting number of ways in a situation, how to split it between three things, being selections, arrangements and distributions. Selections, distributions and arrangements. So in this lesson we are focusing on selection and the different aspects or the different question types or the structures and the formulae related to selection. So let's first understand a selection situation in detail. Let's say I give you a situation where you have to select two people from these four, and I want you to count the number of different ways in which one can make the selection. We want to count the number of different ways in which one can make this selection. So since this is a small question, we can actually do the count physically. So if I count my selections of two people from four, my first selection is if I select AB, my second is if I select AC, my third is if I select AD, my fourth is if I select BC, the fifth one is if I select BD, and the sixth one is if I select CD. So I have a total of 6 selections possible, and the answer to this question, which was asking me the number of possible selections or the number of ways in which I can make this selection, this answer is turning out to be 6, right? But if I give you a situation where you have A, B, C, D, E, F, J, K, L, M, N, O, P, 16 people, and I want you to select 8. So you can't make that list like we made it inside this box, because it will be too long. The list, the count here, as you can well appreciate, is if I start my count with A, B, C, D, E, F, G, H, then my count will continue with A, B, C, D, E, F, G, I, and there will be so many other cases which is not possible to visualize or physically count. And hence, in order to handle this situation or that situation, you need the NCR formula, the formula for combinations, which is also the formula for selections. And what this formula tells us is that if I have n distinct, and this is an important word here, please note this, because if I don't use distinct, then the question might change, as I'll come to you in a little while. So if I have n distinct objects or people, and from them I have to select R objects or people, and I want to count the number of selections in this scenario, then the answer would be given by the formula NCR. NCR counts this for you, and the formula for NCR is n factorial upon R factorial into n minus R factorial. And an interesting thing about this is this formula does not have a name for a person. So if you look through maths, you know that the Pythagoras theorem, for example, is related to one person's name. And if you try to visualize why this might have happened, and I'm just conjecturing here, this could be because maybe this cannot be traced to any one person, which means that multiple civilizations across the world in those ages, when maths was getting developed, knew this formula. So nobody would claim that I have discovered this formula. So this is a formula that one needs to know, and this helps you count any counting situation where these conditions are met. You should have n distinct objects and you're selecting r from n distinct objects. So whether you talk about selecting 2 from 4, the example we took where we wrote all the cases, which would be 4c2, and 4c2 is, according to the formula, 4 factorial divided by 2 factorial into 2 factorial, which ends up as 4 into 3 divided by 2 into 1, because the basic logic of factorial is that 4 factorial can be written as 4 into 3 into 2 factorial, and when you divide that by 2 factorial into 2 factorial, this value gets cancelled, and 4 3 divided by 2 1 gives me a value of 6. Or for that matter, if I am selecting 8 from 16, remember these have to be distinct objects. That's a very important construct in this chapter. From 16 distinct objects I am selecting 8. The answer in this case would be 16C8. Although because this count is going to be very large, in such situations they will not ask you the answer in numerical terms. They'll leave it with the options only as an NCR value or an NPR. They'll put you 2-3 options to confuse you. But as far as you understand this, having the same conditions as this, that you have n distinct objects where n in this case is 16, and you're selecting r from them. Obviously in this scenario it goes without saying that the value of r should be less than or equal to n, because from 6 things you cannot select 8 things. So that's logical, and this is the NCR formula. Now before I move into questions based on this formula, let me show you a couple of more things about this. The first is the factorial. So when you talk about the factorial, 5 factorial basically means 5 into 4 into 3 into 2 into 1. It's the product of all the natural numbers starting from 1 to that number, right? So n factorial can be written as, it can be written both ways, 1 into 2 into 3 up to n, or it can be written as n into n minus 1 into n minus 2 all the way to 3 to 1. Either way is the same thing, because in multiplication the order does not matter, and factorial is only defined for whole numbers. They are not defined for natural numbers. Next point, and the value of 0 factorial is always 1. It's a definition of factorial, and as I showed you, this is a very normal move in using factorials. That 7 factorial, for example, can be written as 7 into 6 factorial, or it can also be written as 7 into 6 into 5 factorial, because the moment you are attaching a factorial to this to the end, you are multiplying it by 5 into 4 into 3 into 2 into 1, which is giving you the answer that you require there. So this is what a factorial means, and coming back to the NCR formula, although the formula is n factorial divided by r factorial into n minus r factorial, you actually don't need to use all that, because you should know how to write the value of an NCR directly. So for example, if you're selecting 3 objects from 8, the solution of this can simply be got by 8 into 7 into 6 divided by 3 into 2 into 1. And this value, because 3 into 2 into 1 will cancel the 6, this value will be 56, right? So what did we do? A 7C2 can be written as 7 into 6 upon 2 into 1. A 15C4 can be written as 15, 14, 13, 12 upon 4, 3, 2, 1. Right? So what we are doing is, in the denominator we are just taking the factorial of r. In the denominator we are just taking the factorial of r. In the denominator we are just taking the factorial of r. When I want to write 8C3, I put 3 factorial here. In the numerator, I start with 8 and take 3 terms, which the 3 is getting counted from here, right? So this is the direct way of writing a factorial. And of course, there's a couple of more things in factorials you need to know, and that is one formula again in factorials is NCR is equal to NCn minus R. This is another formula you should know, and this formula comes from the logic that the number of selections of R things from n distinct things is the same as the number of rejections, number of ways of rejecting n minus R things from n things. What do we mean by this? So let's say a scenario. Let's say from 7 people you're asked to select 5. So this scenario, the list that you'll make of selection of 5 and count of that list will be equal to the list you'll make and the count of the list if from 7 people, instead of selecting 5, you reject 2. So from a list of people, if you make a list which is rejecting 2 out of 7, that list in terms of its count will be exactly equal to the list that you will make on this side. And that is why, based on this logic that the number of selections is equal to the number of rejections, the number of selections of R things is equal to the number of selections of n minus R things, you come up with the formula NCR is equal to NC n minus R. But the way I want you to store this in your mind is numerically, not in this formula form, because you're never going to be required to use it in that form. You should have the numerical reaction. And the numerical reaction is from 16, if I want to select 13, is the same as selecting 3 from 16. And hence, using these two logics, if I am ever forced to calculate a 16C13, I do not calculate 16C13, but I calculate 16C3, whose value I know with as 3 factorial in the denominator, and 16 into 14 into 15 into 14 in the numerator. So this will cancel, this will become 5, and that will become 7, because this was 3 into 2, and this cancels, and you get a value of 560 happening on this side. So 16C13 is 16C3, which is 560, and obviously doing the same writing with 13 factorial in the denominator would be very cumbersome. So whenever you have a large R and a smaller n minus R, use the n minus R first. The values are anyway going to be same. So this is the next thing about the NCR formula that you should know. Please do practice this, and please do practice writing all this. And the last couple of things before I wind up this lesson is that the value of NC0 is always 1. And this is logically, this can be seen through the formula also, because NC0 will be n factorial upon 0 factorial into n factorial. So everything is going to get cancelled. And this can be understood logically also, that if there are 10 people out of which you want to select 0, there's only one way of doing it. There's only one group, that is the null group. You have no other group there. And the second part of this is the second formula or the second understanding of NCR is that the value of NC1 is always n. It's also equal to the value of NC n minus 1. These two are equal always. And the value of NC2 you should know as n into n minus 1, because there are a lot of questions based on this. So you should know the value of NC2 as n into n minus 1 by 2. Again, based on the same logic of writing the number directly. Do factorial in the denominator and two terms starting with n in the numerator. So these are things you should know about NCR. In the next lesson, on the other side, we'll go to start looking at uses of the NCR in questions. And as I said, if you understand selections, you will automatically understand a lot of things about permutation combination, right? So I'll take a leave for the time being, and I'll be back soon with the next lesson. Bye bye.